Hello, I'm Pat Killianey with Yamaha Professional Audio. In this video, we'll take a good look at AES67, an audio networking standard that has garnered significant industry interest. AES67 finds itself in a serendipitous, right standard at the right time scenario. For all the right reasons, its impact is quickly rippling beyond its intended audience in the audio world. Now, while this sudden stardom and quick adoption is exciting, it can be confusing as different segments of our industry describe AES67 in different terms. So in this video, we're going to return to AES67's core message, interoperability. We'll start with a big picture explanation of the problem AES67 was intended to solve. From there, I'll bring in some colleagues for a demonstration using AES67 to connect devices from 4 different network solutions. Finally, we'll have a discussion of where we think AES67 fits, and we'll offer some tips so that you can enjoy the same success we had in our demo. Now, let's kick this off with an explanation of the problem that AES67 was intended to solve. When audio networks first came into use, they were spread out like distant kingdoms among vast fields of analog. The audio networks were really viewed as an operational unit, and anytime we were leaving the network, we were going to a device that only had point-to-point connections, like MADI, AES-CBU, or analog. As audio networks grew in popularity, they incorporated more of our audio infrastructure. And today, different network solutions often run right up to one another. Now when we leave our network, we're probably talking to another device on another network. But we're still treating it as if it's a device that only has point-to-point connections. Let's see how this plays out. Here I might need a lot of channels, so I bridge the 2 networks with MADI. At another link, the need might be smaller, so AES-CBU or analog suit the need. Each time we need another bridge, we certainly add more hardware, complexity, and cost. But more importantly, we're losing the advantage that the networked environment offers, such as higher channel counts, more flexible signal splitting and routing, and a consolidated clocking architecture. Now, I'm happy to say that the AES standards groups saw this challenge coming. They imagined AES67 as an open interoperability standard that could be used to speak between devices, regardless of which network solution your system was based on. Now, this premise sounds like we might be creating a problem of our own. Are we really solving the problem of too many networks with yet another network? Does everybody have to throw away all of the equipment they have and buy in all over again? No, AES67 is not another network. Now, this difference between a network solution and an interoperability standard has precedent. Let me make an analogy using word processors, if you roll back to maybe the mid-2000s. We have many solutions available for word processing, such as Microsoft Word, Corel Word Perfect, Google Documents, or OpenOffice. Each of these systems had their own file format where they could store everything in a fully recallable way. If I was using Microsoft Word and I wanted to send a file to a coworker that I knew had Microsoft Word, I wouldn't hesitate to send them a native Microsoft Word doc file. However, if I knew the person receiving my file had another word processing solution, I might choose to send them a more simple file format, like an RTF or a TXT file. The text of what I wrote would still be there, but we may have to forego publishing features, such as superscript, footnotes, table of contents anchors, things like that. But the point is, the Save as Text file option didn't give us a completely new word processing application. It just gave us a common format where we can move data between competing platforms. Platforms that continue to innovate and give us new features that we put to use every day. So, let's see how this applies to the world of audio networks and AES67. If we look back at our map of audio networks, imagine each network device is like an airport in a different city. Here we have a small system, and the links between them are like domestic flights using our advanced network solution. As systems pop up around the map, some teams may choose products that lead them to a specific network solution. Now let's suppose we have to get audio between devices that are on different network solutions. If the devices are AES67 capable, that's like the device acting as an international airport. Now we can use AES67 to send audio from one network to another. And as you have more devices that support AES67, we can establish more international routes as needed. While this isn't a requirement of AES67, it's worth noting that many of our devices will be able to support our native solution and AES67 at the same time. So AES67 does not displace our existing network solutions. As a matter of fact, I think most will agree that our existing solutions offer advantages over AES67, such as simplified setup, lower latency performance, and better control integration. So just as the text file didn't create a new word processing application, AES67 won't create a new network. I think most of you will continue to use your native network solutions, complete with their advantages and a rich feature set that they offer. Now, when we speak of AES67, you may hear of the Media Networking Alliance. The Media Networking Alliance was formed to promote the adoption of AES67. Its members will work on educational efforts, like this video. We'll get together at plug fests, where we all bring our equipment and plug it in together and make sure it's going to work properly. And we'll work together on demonstrations at trade shows. As you can see from the member list here, there is a significant mix of manufacturers, suppliers, and customers all working together to ensure the designs meet expectations. Okay, so it's demo time. Now before we get started, there are a few things that some people wanted to make explicitly clear. First, our demo will use multicast streams only. So AES67 does call for unicast and multicast methods of transmission. However, the only universally supported method amongst all M&A members is multicast. Now, if unicast and multicast are foreign terms to you, that's okay. That's not critical to understanding what you're seeing in the video. However, if you want to learn about that, and if you're watching us on YouTube, look in the video description just below this window, and you'll find a link to a video called Optimizing Audio Networks. There's a tutorial in there that will explain unicast and multicast, so check that out. Okay, so multicast only. Got it. Devices not supporting SAP used the Ravenna to SAP utility. Okay, so this had to do with an issue called discovery. Now this is a critical thing to understand. So right after the demo, we will have a discussion at length of discovery and this utility. So stick around for that. Some devices are running development firmware expected to be available at the end of 2016 or early 2017. Basically, we treated this video like a trade show demonstration, where so long as it's going to be available in the near term, that was acceptable. So with the disclaimers out of the way, let's send it down to Seminar Room 2, where the demo is all set up and ready to go. Hello and welcome to this video demonstration of AES67. I think this will be one of the most thorough demonstrations of AES67 to date, so I think we're all in for a treat. And I'd like to thank my colleagues who came together, bringing equipment representative of different applications. While this is a small setup, we know the technology scales up nicely. So let's start off with a brief introduction and a quick tour of what we've set up.
Hi, my name is Martin Barbour from QSC. I'm very pleased to be able to show you our QSys platform as part of this AES67 demonstration. What you see here is a compact QSys demo system, which includes a QSys Core 110F processor, a TSC7T touchscreen controller and AV bridge, as well as the CXDQ networked amplifier. All the QSys connected devices that you see here are running Q-LAN networked audio over a standard network switch.
Hi, I'm Killianey with Yamaha's Professional Audio Division, and I'll be representing Dante with a live PA and multi-track recording system. The live PA is represented by a Shure ULXD wireless system, a Yamaha R-Series stage box, a CL mixing desk, and power amps and speakers by Nexo. We're recording the sound for this video in Steinberg's Nuendo Live. Everything in this station is connected using Dante, running across Yamaha's SWP1 network switches.
Hi, I'm Andreas Hildebrand with ALC NetworX. I'll be representing the Ravenna open technology approach for professional audio networking. The Ravenna demo we have today is representing an OB-WAN application. So we have a Lavo Crystal mixing desk and an I/O node from Lavo. We have a single channel microphone preamp. We have an IP-connected monitor speaker from Genelec. We also have an in-rack monitoring system from Waldbeck. And everything is nicely connected through a standard switch provided by Yamaha. Also for playback, we have a virtual sound card sitting on a standard PC.
And I'm Kirk Harnack with Axia. We're going to be talking about Livewire and Livewire Plus that includes Ravenna and AES67 AOIP networking in it as well. I've got a typical radio studio here with a Radius console, a Core 16 mixing engine, also an X node. That's Axia's I/O device for legacy things that don't yet speak IP. And the Axia X switch, a zero configuration switch that handles all these audio over IP networking standards. We'll be looking at all these and see how they work together and how they work with other AES67 compatible equipment.
Now, as many of you know, our network solutions are not limited to the applications we're showing. We just mean to create a scenario where it's easy to visualize different teams on different systems working together across the network. And speaking of that, you may have noticed our microphones are plugged into our individual network solutions. I'm bringing them together in the CL3 and then down to the recorder. So you're hearing AES67 audio right now. Now, earlier in the video, we mentioned many platforms could support our native networked audio solution and AES67 at the same time. That's what we're doing here. So now, let's take a closer look at each system and how we pull in an AES67 stream and how we provide one to the network. To start things off, I've already provided a stream from my Dante system, and Kirk is going to go ahead and pull this in on his Livewire system.
Now that there's an AES67 stream on the network provided by the Yamaha console through their Dante interface, we're going to pick that AES67 stream up over here on this Axia Radius console and play it through the console. Let's see if we can do that. We'll take a look at the Core 16 control center. That's the console's control center. And we're in these source profiles. We're going to create a new line input, and we're going to give it a friendly name. Let's type in Yamaha PGM program. We'll call it that. That will appear on the console. The source input is not coming from a Livewire AOIP source. It's actually coming from an AES67 multicast source. That's probably the most common style of AES67 stream out there. Now, the only requirement here is that I know the multicast IP address that this stream exists on. It's 239.69.33.49. I know that because they told me. So there we go. Now, let's scroll down and hit OK. And now it is going to be a source there. It appears Yamaha PGM is now a source available on the console. So now I'll slip over here to the console itself. Fader number 8 is currently unassigned, and I'm going to hit the assignment button here to choose what source is coming in. We'll scroll down through the list, and lo and behold, there appears Yamaha PGM. And now we will exit out. We see Yamaha PGM on the fader. Turn it on, turn it up, and listen. Now that we've received an AES67 stream from a Dante system, let's look at how we generate an AES67 stream in Livewire Plus so that Dante or other systems can receive that AES67 stream. Let's give it a friendly name here. How about Axia Music, since we're playing a music file through this source input. And we're going to give it an Axia channel number. How about 838? That kind of falls in line with my numbering scheme here. By the way, in the same place, you could put just a multicast IP address, and that would work as well for any of these stream types, but it's easier just to put a channel number in there, and the node will turn that into a multicast IP address. Now, as far as the stream mode, we can't choose live stereo to have compatibility with AES67. We need to choose low latency stereo. So we'll choose that one and hit apply. Now, when we hit apply, what we find is that the X node figures out for us the SDP file. That's the stream description protocol file. And also it figures out an RTSP address for us. That'll be important if we want to do something with Ravenna, if we don't already find it with the Bonjour protocol. And the SDP file, well, that's pretty interesting. And this is the SDP file for the stream that we just made. There are some AES67 devices that will want the information in this file in order to pick up the stream. So you see that with Axia, with the X node, when you make a Livewire plus stream, you're actually making streams for AES67 and for Ravenna as well.
So now that Kirk has generated a stream from the Livewire system, we want to see how to get that stream into the Ravenna side of things. I turn to the web page of the Crystal desk. You can see that the different streams are lined up here. And now we want to connect the Axia music stream. And as you can see in the drop-down list, it's already appearing. So I just select that stream. And basically, it fills in all the required data from me through the advertisement and RTSP protocol. And finally, I just hit apply. And the stream is assigned down here, and it's on the fader number 6. So now that we received the stream from the Livewire system, we want to create our own stream to distribute it to all the other AES67 devices. So in the TX stream section of the user interface, we want to create a stream containing the program of all sources we have on the faders. So we choose create. And as you can see, the payload type offers us several pre-default stream profiles. And of course, we're going to choose the AES67 standard stereo stream. We want to assign a nice name for that stream. Let's say Crystal PGM 1 and 2. And now, usually, the Ravenna system automatically assigns a multicast address. However, in order to actually make this stream receivable by all the connected devices, we have to assign a multicast address from a valid range of multicast addresses. So let's choose 239. We know it needs to be 69. And then we choose 61.1. So that will be the multicast address under which this stream would appear on the network. So at the very instance I hit apply, you can see that the stream now is appearing in the TX stream section. And if I open the fader, Patrick should be able to see that stream on his Dante system.
As a matter of fact, I do. As we go through this demonstration, each of us is pulling in every AES67 stream generated by somebody else. Not only do we have each other's microphones, but we have each other's stereo streams as well. At this point, I'd like to turn it over to Martin so he can show us how to pull in an AES67 stream on a Q-LAN device.
So those of you familiar with our software will recognize these yellow blocks on the left-hand side being either physical or network-based inputs. So here we have an AES67 block configured for 8 channels or an 8-channel stream. And down here we have stereo blocks. So what I want to show you now is an AES67 receive from Andreas's Lavo system. So here we have an unconfigured AES67 receiver block. Please bear in mind that this is a pre-release version of software. So when we get to release, this will be a much simplified user interface. So we know that Andreas is transmitting on a multicast .61.1. So if I pull up that stream, you'll see that the receiver block configures itself, and now you see the AES67 format audio coming from Andreas's Lavo system. I get a chance to listen to it. So that's how we set up a receive stream via AES67 into the Q-SYS core natively. What I want to show you now is how we set up a transmit stream from Q-SYS to another platform. So again, in the offline mode, we add our AES67 format transmitters. So here the mono transmitter is the microphone, which you've been listening to throughout this presentation. That's sending my microphone directly to the CL mixer. Here, I have a stereo transmitter, which I'm going to send back out onto the network for someone else to receive. So I'm going to switch now to our online version of the file, and here you'll see, again, a development version of our AES67 transmitter user interface. I simply need to enter a valid multicast IP address. And in this case, our system has been configured for this IP address. So when I enter that, my stream is now live onto the network. So at this point, I can unmute and start passing AES67 formatted audio onto the network.
So now I'll take that AES67 stream that Martin just made on Q-LAN and I'll pull it into our Dante system. In the routing grid, Dante controller is showing me native Dante devices in black and AES67 streams in blue. Patching AES67 works just like patching a Dante stream. Here's the stream that Martin made. I'll come down here and I'll patch it into my system by checking the boxes on the grid. I'm going to pull up the fader. And there we go. So, as AES67 was added to the Dante environment, Audinate gave us more filters to help us sort through all the devices and streams in Dante controller. At the top of the network view, you'll see a relatively new button which toggles the filter pane. In here, you'll see there is a list of AES67 qualities to search for. We can choose to only view devices that are AES67 enabled, which is an easier way to find AES67 capable devices to land a signal to. Or, if we're looking for a new place to land a stream, you might search for disabled devices. The disabled search shows you devices that have AES67 capable firmware on it, but you haven't enabled those functions yet. To engage the AES67 functions, double-click the device and select the AES67 tab. Again, this tab will only show up on your device if you have AES67 capable firmware on it. Go to the drop-down menu to engage AES67. Then, we need to come down here and select a specific range of multicast IP addresses to use for our AES67 streams. Now let me jump to another device where it's already set up, and you'll see what the screen will look like. Once you have your AES67 routines engaged, you can create multicast AES67 streams just like you would create a multicast stream in Dante. Click the multicast button here at the top. Then go down the list and check any channels you would like to put in the stream. Back at the top, we'll see we can click to make this an AES67 multicast flow, then click Create. At this point, we've created an AES67 stream that can be pulled in by anybody else on the network. Now, if you're working with somebody who has to manually configure their system, you can look in the Transmit tab of your device and you'll see the multicast address and the AES67 session ID. So, at this point, I think we've come full circle. Every one of us has created a stream and every one of us has brought one in. I'd like to thank my colleagues who have joined me for this demo. Martin Barbour with QSC, Andreas Hildebrand with ALC Networks, and Kirk Harnack with Axia of the Telos Alliance. I'm Pat Killianey with Yamaha's Professional Audio Division. Let's go back up to the workshop where we'll cover some frequently asked questions and some technical details that will help you set up your AES67 connections. All right, well so far we've gone over the concept of AES67 and we've seen it in action. Now it's time for a more technical discussion. As promised, we'll certainly cover this issue of discovery. I'll also offer some ideas on the right time to use AES67 and when it might be more appropriate to use something else. And finally, I'll offer some tips on commissioning the network. So let's dive right into this topic of discovery. The AES67 standard did an excellent job of getting very specific about many elements of audio networking. It isn't important that you memorize all of these protocols, but for those who are interested, the word clock that might have been transported on a BNC is handled using Precision Time Protocol version 2. You could also imagine the XLR streams getting connected and running across a network. That portion might be covered using RTP or IGMP version 2. Now all of this is possible if Dante controller knows about all of the sources and destinations on the network. So how does Dante controller know that these other devices exist? I didn't tell it. I just took my computer, plugged into the network, launched the program, and the list populates automatically. Well, in Dante and in other network solutions, audio endpoints will advertise themselves. This is a process we call discovery. and Dante uses a discovery method called SAP. Now this is similar to a newspaper boy standing on the corner and yelling, "Extra, extra, read all about it! Front of house console with a stereo main and mono sub, 48K, 24-bit. Dante controller would hear that announcement, add it to the list, and now you can get to work patching it. Now, if the device that you're using as a source doesn't have an SAP announcement, Dante controller will never know about it, it won't show up in the list, and you'll never be able to patch it to an AES67 enabled Dante device. So this is fairly important. So what does the AES67 standard say about discovery? Well, it acknowledges 4 different discovery methods, and SAP is one of them. However, it draws no conclusions on using any of them. So this is a conundrum, and how you interpret this will probably depend on the nature of the network solution you're coming from. If you're Audinate, where discovery is an integral part of your ecosystem philosophy, then you would say the discussion of discovery implies an intent to achieve discovery. However, if manual configuration is the norm on your platform, then you would say no discovery method was required, therefore the only solution is manual configuration. Well, both premises are supported by the specification, but neither conclusion is there. They're both leaps of logic. And thus we have a problem. Some devices support SAP and some don't. But where there's a will, there's a way. In our demo, we used a Windows program called Ravenna to SAP. You can think of it as the glue or the gaff tape just holding these 2 pieces together. Here's how it works. Ravenna uses a discovery method called Bonjour. This utility will convert existing Bonjour discovery messages from Ravenna devices into SAP discovery messages for Dante controller, and vice versa. This utility also allows you to manually craft discovery messages and send them as Bonjour or SAP messages. Now you can bridge the gap between any AES67 devices regardless of which discovery method they support. And I'll point out this utility is only getting involved with the discovery message, which is a very small amount of data that gets transmitted maybe once every 30 seconds. Once the audio starts flowing, it goes from one audio device directly to the other. It does not have to flow through this computer, so you don't have to worry about overloading this device as you start patching more streams. So without stealing any more of his thunder, let me turn this over to Andreas, who will give us a tour of the Ravenna to SAP utility.
The Ravenna to SAP converter has 3 main areas where the different announcements can be seen. On the left side, we see all the streams announced through Ravenna Bonjour. On the center part, we do see the SAP announcements originated by the Dante system. And on the right side, we have an area with a local stream announcement. I'll come to that later on. Now on the left side, you can see we have a bunch of streams announced through Ravenna. And if I want to make one of these or multiple of these streams available in the Dante system, I just select the Crystal program output and translate it into the SAP side. And now, at this very moment, the stream is actually visible in the Dante controller. Just the same way, we can translate streams originating from the Dante side of things into Ravenna announcements so that the Ravenna devices can see the Dante streams. Let's select this particular stream coming off the Yamaha console. I translate that into the Bonjour area. And here's our Yamaha stream, which is now visible on the Ravenna side of things. Not all Ravenna devices require this utility. Some Ravenna devices also natively support the SAP protocol. So here's the Crystal program stream, which I created earlier. And as you can see, it's currently up for the Ravenna native advertisement. And if I activate the SAP button, then an SAP announcement will go out in parallel to the Bonjour announcement. So if I apply and I look into my utility again, you see the Crystal PGM stream is being advertised as Ravenna announcement, and it's also advertised as an SAP announcement. For devices not supporting Ravenna Discovery or Dante's SAP announcement, the utility offers the option to create an advertisement from manual entry of SDP data. For this example, Kirk handed over an SDP data from his Axia music stream, which I can open up here in an editor. I'll copy this data, go back to my utility, create a local stream advertisement from this data. I fill it into this box. As you can see, the stream name is channel 21256. If you're not happy with that and want to give it a name to be better recognized on the other system, here's the S line, which allows you to assign another name to it. Hit OK. And once I start the translation, the stream is showing up on the Dante system as Axia music stream. The Ravenna to SAP converter is freeware, and it can be downloaded from the Ravenna website at ravenna-network.com.
All right, well, thank you, Andreas. Now, as he said, some manufacturers are providing direct support for SAP so that you won't need a utility like Ravenna to SAP. For example, Merging, Archwave, and DirectOut adopted SAP early, and they're already shipping AES67 firmware with SAP support. In our demonstration video, you also saw Lavo and QSC both supporting SAP directly. Of course, any Dante company that's adding AES67 support will inherently have SAP. Now, this is a list of companies who have products that support AES67 with SAP, and those products are either available today or they will be available by the first quarter of 2017. There are more companies headed this way, but their product roadmaps are a little further out. So to sum this up, SAP announcements are required for an AES67 stream to show up in Dante Controller. For devices that don't support SAP, you can bridge the gap using a utility like Ravenna to SAP. All right, so now let's move on to the next topic. When is a good time to use AES67, and when might there be a better alternative? Let's start this discussion by pointing out our native network solutions offer advantages over AES67. For example, the simple fact that everything was designed by a small group of people with a single mindset means conventional thinking prevails. Basically, it's easier to use because as I go from device to device, I have a very consistent approach in my interface, in the menu structures, and all of that. And I think that was apparent in the demonstration. Every time we created a stream, we went into one utility on one platform, and to pull it into a device, we went into another utility on another platform. Now, this isn't terribly difficult, but it is more work than doing everything in a unified platform, and that advantage shouldn't be ignored. So another advantage is lower latency. Just about everyone will find the sound of their own voice more pleasing with lower latency. And this is a fairly easy one to understand. If you plug your ears and talk, you'll find that you can still hear yourself quite well. You're not hearing the sound of your voice coming out into the air and then through your ears. You're hearing all the elements of your voice vibrating with a mechanical connection directly to your eardrum. Now, the longer the sound of your voice takes to get through a sound system and up into your headphones, the more out of time it is with this mechanical connection. And you start to hear a phasing artifact. Now, most people will not identify it that way. They'll just hear this comb filtering problem, and they'll probably ask for an EQ change. But remember, the only person that hears this phasing problem is the person talking. So the audio engineer is left to solve a problem that they cannot hear. Now, to solve this problem, many of our audio network solutions can achieve significantly lower latency over the network. If I diagram this, you might see some time for A to D, local processing, and certainly some time in the mixer or the DSP. But that part in yellow is the network traversal. So in this case, our network is using a latency of 1/4 millisecond for each trip, and the total system time is 3.1 milliseconds. Now, if we flip this to AES67, the only required latency setting is 2 milliseconds. With no other changes in the system, this would add 3.5 milliseconds to the network traversal time, pushing out the total system latency to 6.6 milliseconds. Now, how much latency can we have in a system before it presents a problem? Well, that's a subjective question to be sure. I think most audio professionals will agree that anything over 10 milliseconds, that's a definite red zone. You do not have to be an audiophile to hear that difference. But when we're designing a system and we know people are going to hear the sound of their own voice back, many of us may try to keep it under 5 milliseconds. Now in this example, we can see that AES67 kept us out of the red, but it definitely pushed out into a gray area. Okay, so we've suggested native solutions offer easier operation and lower latency performance. Another advantage would be advanced control and integrated diagnostics. In our utilities, we can often offer a glimpse into the stability of your network. For instance, here I can show you the accuracy of the clock, as well as how long it takes to get audio packets across the network. And this is not a pass-fail proposition. I can get real metrics that will tell me whether my system is doing well or whether it's struggling a bit, and I might be wise to take some corrective action. Another area that native solutions offer an advantage is security. I can take mission-critical devices and lock them. Now, people won't be able to unpatch that, whether it's a malicious intent or purely an accident. Now, control and integration extends well beyond diagnostics and administrative tools. It goes right into tangible features inside the products themselves that designers and audio engineers alike depend on. For example, if I'm connected to a mic preamp somewhere else on the network, I can control its gain or its phantom power. If I'm connected to a wireless system, I might be able to get mission-critical information like signal strength and battery level. So the point is, our native solutions offer far more than just audio transport and clocking. The smooth user experience, the lower latency performance, and the rich integration are just 3 features that I think most users can relate to. So, when would I use AES67? Well, imagine an event at a stadium. One team handles the live sound and another pulls up in a broadcast truck. I would take all the gear that the live sound group needs, draw a circle around it, and try to keep that group under one network solution. Then I would do the same for the broadcast team. Draw a circle around all their gear and try to keep it to a single platform. Now when the stadium needs to provide signal to the broadcast truck, I think that would be a great time for AES67. When I'm designing my system, I'm no longer concerned with what network solution is on that broadcast truck. It could be a Dante truck, a Ravenna truck, a Livewire Plus truck, a Wheatnet IP truck, right? It doesn't matter. By using AES67, I reach a level of interoperability that I may have only associated with MADI. However, I get to keep all the advantages of a networked environment, such as higher channel count, more flexible routing and splitting, and a consolidated clocking architecture. So that's where AES67 was driving at the beginning. But now it's expanded a bit. Video teams are looking to replace their SDI video infrastructure with a network-based solution. And there's been tremendous movement on this in the last year. You might hear about standards like SMPTE 2022, maybe TR03 and TR04. In these standards, when it comes to audio, they've chosen AES67 as their transport. So now, not only can we use AES67 to communicate with other audio teams, we could use it to exchange audio with the video team. And that makes it really interesting. Now, this brings up an interesting question. What did the video world do about this issue of discovery? Well, they didn't choose SAP or any of the other discovery methods in the AES67 spec. Currently, it looks like they're heading towards a discovery method called NMOS. Now, it's too early to tell whether this will be integrated into our tools like Dante Controller, or whether this will also require an external utility. Time will tell. For now, just put NMOS in the back of your brain and know that it is something like SAP. and probably over the next year this will become more clear. So to sum up this issue of when to use AES67, I would use it to link separate teams together. However, when I'm designing a system for one engineer or one team, I would try to keep all of that system on one native network solution. For a number of reasons that we've outlined already, their lives will be made a lot easier. Now, if there's a compelling piece of gear that's only available on another network solution, certainly you could use AES67 to bring that in. But I would try to minimize how many times I have to do that. I would try to keep things on a single network solution. So finally, that brings us to our last topic, network commissioning tips. As we've set up at plug fests and demonstrations, we've learned a thing or two about how to design a network that will support multiple audio network platforms and AES67. So here's a few tips. Job number one is to establish a clock master. If you're using AES67, chances are you're linking multiple audio networks together. Some of them will clock using PTP, Precision Time Protocol. Others will use PTP version 2. Now, there's no problem with those two being on the network at the same time. They can coexist, that's fine. But because they're coming from different systems, they're not necessarily resolved to each other. So when you're choosing a clock master, it helps if you choose a device, obviously, that won't leave the network. But if you also choose a device that supports both network protocols. Now, in a large network solution, you might have a grandmaster clock that supports both, and that's great. But in a smaller scenario, if you have a Dante device, that's an example of a device that will support both. Dante uses PTP, AES67 uses PTP version 2. So you'll have a single clock source that gets coordinated out to both platforms, rather than having one protocol chase the other. So that's tip number one. Now the next thing to talk about is network switch settings. The first one is universal to all audio network solutions. You want to turn off green Ethernet, also called energy efficient Ethernet, EEE, or the standard number is 802.3AZ. If you see that on your switch, you want to turn it off. Right? Now the next thing has to do with IGMP snooping. Because we're using a lot of multicast traffic with AES67, IGMP snooping is a great way to reduce the clutter on the network. Now, AES67 calls for IGMP snooping version 2. If you set your switch to version 3, theoretically it should fall back to version 2 if it sees that invoked. But we've seen some switches not do that very well. So whether you want to do this as a corrective action or you want to do it preventatively, think about setting your switch to IGMP snooping version 2. Finally, let's have a conversation about quality of service. Quality of service allows us to prioritize some network traffic over others. Let's suppose a network switch has some web traffic and some audio traffic destined for the same network port. The switch could decide to send the audio data first, regardless of the order these packets were received in. This allows the audio to move through the network unimpeded. We do this by tagging packets with DSCP values. The switch can use these values to set the data packets in different priority queues. We would put clocking packets in the highest priority queue, audio packets second, then control data or anything else. Now, different network solutions use different DSCP values for each type of traffic. And AES67 is no different. In fact, its DSCP values stand in opposition to the values used by Dante. AES67's highest priority for clock is the same as Dante's second priority for audio packets. Now thankfully, Audinate already addressed this in their firmware. They had to devise a coherent quality of service approach that would maintain backwards compatibility with legacy Dante devices while still working with AES67 going forward. So, Audinate decided to transmit Dante and AES67 using the traditional Dante DSCP values. So now we only have to address this when you want to implement quality of service and you want to link to another audio network solution. The easiest solution is to simply blend the two DSCP schemes into one hierarchy. While this isn't an ideal situation, it's certainly easy to implement, and in a practical sense, it would work for most networks. Now, if you really want to meet the ideal, you could look in your switch and see if there's a feature called DSCP retagging. DSCP retagging instructs your switch to inspect packets as they come or go, and anytime it sees one DSCP value, you can instruct it to substitute another. So, you could use this to translate from the Dante DSCP scheme into the AES67 scheme, or vice versa. So what I would do is look at your network, and whatever the dominant DSCP scheme is, that's what I would set up on my switch. And then whatever devices follow another scheme, I would translate them as they come into my network. Another solution is to use separate switches. So you could set up one switch optimized for Dante, another switch optimized for AES67, and then you would only have to retag on the link between the switches. Now let's suppose you had two teams, and each one was allowed to choose the audio solution that best fit their need. This is what your solution might look like. Realistically, each team would have their own network switches optimized for their platform. There's only one point where their system is linked either to each other or to the center of a star, so you could do your DSCP retagging on the point of egress. So that pretty much sums up our network configuration tips. Set your clock master first, hopefully something that supports both PTP and PTP version 2. Turn off Green Ethernet. Think about IGMP snooping version 2. And if you're going to implement quality of service, think about how you're going to handle these conflicting flags. Well, I think that just about covers it. At this point, you are an AES67 expert. We started off with a glimpse at what AES67's original mission was. We offered a demonstration of AES67 in action, offered tips to help you duplicate the success we had in our demo, and we offered suggestions on where AES67 fits and where there might be a better solution. I'd like to thank my colleagues who came together to help make this demonstration video a reality. I think their contributions made it significantly more interesting. I'm Pat Killianey with Yamaha Professional Audio. Thank you for joining us, and we'll see you around.